Hi everyone! Today we're going to be talking about Venn diagrams. Our objectives for today are that students will be able to represent conjunctions and disjunctions using Venn diagrams. Let's get started. Alright, so we've previously talked about conjunctions and disjunctions, and today we're going to describe or learn about how to describe those conjunctions and disjunctions using Venn diagrams. So Venn diagrams are just a visual way of displaying the relationships between two sets. So for example, we have three different types of Venn diagrams. First, we have our all, always, every Venn diagrams. And they're always going to look like this. So they're always going to be a circle inside of another circle. And what this is saying is that all elements of P are elements of Q. And the symbolic notation for this is if P, then Q. The second type of Venn diagram that we will see is our sum, is our sum or sometimes Venn diagrams. And they always look like this, all right? Where when we're talking about the inside circle or where they overlap, that is always going to be our conjunction. So that's always going to be our P and Q. The entire Venn diagram represents P or Q, or our disjunction, all right? And basically what this Venn diagram represents is that some elements of P are elements of Q. And last but not least, we've got our third type, our no, none, never Venn diagrams. And this is where we have two separate circles that do not overlap, and this describes a situation where there is no relationship between P and Q. So these keywords that I highlighted on top are very important because as we're reading problems that describe the relationship between P and Q, these are the keywords you want to look for to identify what type of Venn diagram you're going to draw. Alright, so a few examples. We're going to draw a diagram that represents each statement. So number one, the statement says some students who take chorus also take band. So the key word here that we wanted to look for is, I wanted my highlighter again, is some. All right, that is our key word. So the type of diagram we want to draw is two overlapping circles. Okay, so let me see if I can get a circle here. All right, so we've got our first circle that represents our P. And then we've got our second circle that represents our Q. All right, so they're overlapping because some students who take chorus also take band. So what we would want to do is label the circles. So we could call this our chorus circle and this our band circle. And some students who take chorus also take band, and that would be the part that's overlapping. So the students who take both would be the middle, and then we've got the students who only take chorus and only take band. But this is a Venn diagram that represents statement number one. All right, number three, numbers divisible by 6 are always divisible by 3. So our key word here is this word always. So it's going to be one of our all, always, every type of Venn diagrams where if P, then Q. Because all elements of P are elements of Q. All numbers divisible by 6 are always numbers divisible by 3. So when we're drawing our circles, we want to draw it so we've got one big circle. And I don't want a yellow one. Let's try again. Let's do this one. There we go. So we've got a big circle, and then we've got a little circle inside of it because all elements of our inner circle are elements of our bigger circle. So we would say all numbers divisible by 6, that would go on the inside. So I'm just going to draw an arrow here because, let's see if I can write it in there. All numbers divisible by 6, all right? So numbers divisible by 6 are always numbers divisible by 3. All right, because if a number is divisible by 6, it has to be divisible by 3 as well. So this would be a Venn diagram that represents that. All right, number 5, some vertical angles are complementary. So our keyword here would be some, all right? That is our keyword, so we know it's going to be our second type of Venn diagram on our types of Venn diagrams chart. So it's going to be one of those some or sometimes charts where we have 2 overlapping circles. So we want to draw our 2 overlapping circles, all right? And my app allows me to draw perfect circles, but you don't need to worry about that as long as I can tell that they're circles, okay? So here we go. Some vertical angles are complementary. So what we want to do is label these as our 2 circles. So we've got vertical angles over here, and I'm just going to use the angle symbol. And then we've got complementary angles over here. I can't fit it in my circle, that's okay. All right, and where they overlap, so this section right here is those angles that are both vertical angles and complementary angles, all right? So that is the overlapping part because some of them are both vertical and complementary. But then we've got some that are just vertical angles and some that are just complementary angles. All right, so for the next few examples, what I want you to be able to do is shade the indicated region on the Venn diagram. So for example, number 7 is asking you to shade the Q part of the Venn diagram. And because this is a some or sometimes Venn diagram where some parts of Q can also be parts of P, we need to shade all parts where P is. So if we're or all parts where Q is. If we're saying what part of this Venn diagram is an element of Q, we would want to shade the entire Q circle, all right? And that includes the part that overlaps with P. That is also Q because the parts where they overlap is both P and Q. So we have to include that when we're shading our Q section. So it would be this entire circle would be representing the Q region. All right, yes, we're doing an even. We're going to do a few evens because this is a really important one, all right? So I want to be sure to do this with you. So number 8 is saying P and Q, all right? So hopefully you remember that. That little symbol right there means and, all right? It's a conjunction. So the part where it is both P and Q. So if we were to shade that in these types of Venn diagrams, it would just be the parts where they overlap. This is the only area or region of our Venn diagram where it's both P and Q. All right, number 9. Number 9 is saying when is it P or Q? All right, because hopefully you remember that this little symbol right here means or, all right? It's a disjunction. So which parts of our Venn diagram are either P or Q? And essentially that would be the whole Venn diagram. Every single part of this would be either P or Q. So you're going to shade the whole thing. All right? This whole circle is P and this whole circle is Q, and where they overlap is both P and Q. So every part of this Venn diagram is either P or Q. All right, and number 10, we want to read that symbolic notation and understand that number 10 is asking us for P and, all right, that symbol means and this right here means not Q, all right? So which parts of our Venn diagram are P and not Q? So first of all, not Q. If we want to represent what part is not Q, this whole circle represents Q, so we can't include anything in this circle. So therefore, the only part of our Venn diagram that is P and not Q would be this section right here. All right, we cannot include the part that's overlapping because that is Q, and we want P and not Q, so we can't include any parts of Q. So the region that we would shade would just be, oops, I want my shading, we would just shade this part right here because this is the only part that is P and not Q. All right, so the next few examples are a little bit different. We're given a Venn diagram and we want to write either a conditional or compound statement. So just a little review What is a conditional and what is a compound statement? So a conditional statement is anything that's written in if-then form, all right? That is our conditional statement, conditional statements. And compound statements is anything that uses an and or an or, all right? So if P, then Q. That is a conditional statement. Compound statement, when we say and or. All right, so number 11, we're given one of our all-always types of Venn diagrams. So we have a circle within a circle. And what this is saying that all elements of this circle are elements of this circle. So if an angle measures 60 degrees, then it has to be an acute angle. So we would want to write this as a conditional statement or put it in the if-then form. So if an angle measures 60 degrees, then it is an acute angle. All right, so that would be how we would write this out. So if an angle measures 60 degrees, then it is an acute angle. Done. All right, that would be our conditional statement representing this Venn diagram. All right, number 13, we've got two overlapping circles, all right, and this circle represents people who play volleyball. This circle represents people who take piano lessons. And there is a part where they overlap, so some people play volleyball and take piano lessons. So if you heard me use a keyword in there, hopefully you caught me saying the word some, all right? So some is going to be our key word here because some people play volleyball and take piano lessons. So when we're writing our statement, that's what we want to say. So anytime you have these some Venn diagrams, it's going to be a conjunction, and we're going to use the word and. So writing this out, we would say some people play volleyball and take piano lessons. Done. And that is our compound statement that represents this Venn diagram. All right, now number 15 is a little bit trickier, all right, because we have to look at the shaded region. So here we've got a circle representing people who are in art class and a circle representing people who are freshmen. And there are some people who are both freshmen and take art class, all right, but the part that's shaded is the people who are freshmen and do not take an art class, all right, because none of the art class is shaded in. So the region that is specifically indicated in this Venn diagram would be this one right here, and this would be the people who are freshmen and do not take an art class. So we would want to write a compound statement representing this, and we would say that let's see, students who are freshmen. Oops, we want to expand this. And do not take an art class. All right, that is what this Venn diagram would represent. Students who are freshmen and, all right, it's a compound statement still, and do not take an art class because art class is not shaded in at all. All right, so just want to give you a little bit more practice with Venn diagrams so you see some examples of these, all right? So below we have a Venn diagram that shows the number of senior boys who play football or wrestle, all right? And key thing I want you to recognize about this Venn diagram is we've got people who play football, boys who wrestle, boys who do both, and then also over here you've got this number. This 104 represents the boys who do not play football and or do not wrestle, so they don't do either. So there's 104 boys who were surveyed who don't play football and do not wrestle. So that is a key thing we have to notice about this Venn diagram. All right, so starting with question A, how many senior boys play football and wrestle? So the part of our Venn diagram that would represent the boys who play football and wrestle would just be the part that is overlapping. So the boys who play football and wrestle would be 9. Then how many boys senior boys play football but do not wrestle. So the number of senior boys who play football but do not wrestle would only be this part of our Venn diagram. All right, let's see if my pen's working. All right, so it would just be this section right here. That is the part of our Venn diagram that represents the boys who play football but do not wrestle. We cannot include the part that is overlapping because those boys also wrestle. So therefore, how many senior boys play football but don't wrestle? That would be 18. All right, then I'm going to erase this so we can use our Venn diagram again. Now, part C, how many senior boys play football or wrestle? So how many do both, all right, or one or the other? So therefore, the part of our Venn diagram that would represent this is everything that's inside. All right, so it would include all of this circle and all of this circle because there's 12 boys who wrestle, 18 boys who play football, and 9 boys who play both. So what we would do is we would say 18 plus 9 plus 12 because all of those boys either play football or wrestle or do both. So therefore, 18 plus 9 plus 12 gives us 39 boys who play football or wrestle. And then, last but not least, all right, let me erase all this. Last but not least, how many senior boys just wrestle? Or not just wrestle, but how many of them wrestle in total? So the number of senior boys who wrestle in total would be these 12 who just wrestle, right? They'd only wrestle, but 9 boys wrestle and play football, so we have to include them as boys who wrestle. So therefore, how many senior boys wrestle? 12 plus 9 gives us 21. All right, if you're having any trouble with Venn diagrams, understanding anything, please call me over so I can help you. Otherwise, let's move on. All right, so I want you guys to try number 3 all on your own. All right, do A, B, C, D, and E. Remember the key elements of this diagram, of this Venn diagram. We've got 8th grade students who have a smartphone, 8th grade students who have a tablet, 8th grade students who have both, and then 8th grade students who have neither, okay? So try to complete A, B, C, D, and E. When you come back, I'll have the answer written on your screen, and we will go through it together. So go ahead and pause your video now. All right, so here are your answers to this problem. So let's start with A. How many students have a smartphone and a tablet? So because of that keyword and, we want to look for the part where they overlap. So 58 students have both a smartphone and a tablet, all right, because that is where they're overlapping. How many students do not have a smartphone or a tablet? All right, here we would look at that number on the outside because 117 students don't have either. How many 8th grade students are there in total? Well, what we would need to do is count up all the numbers in our Venn diagram that are represented here because 116 students have a smartphone, 58 students have both, 29 students have a tablet, and 117 don't have either. So add them all together and you get 320, and that's how many 8th grade students there are in total. How many students have a tablet? So to find that answer, what we would need to do is look at our tablet circle, all right? And we see that 29 students just have a tablet, and 58 students have both a tablet and a smartphone. So if we add these two numbers together, that would give us the total number of people who have a tablet. And last but not least, how many students have a smartphone but not a tablet? And that would just be 116 because that would be representing this part of our Venn diagram. These people only have a smartphone. These people have a smartphone and a tablet, so we cannot include them in students who have a smartphone but not a tablet. All right, if you have any questions on this, please call me over so I can help you. Otherwise, let's move on to our final example. All right, so our final example is number 5, and in this Venn diagram, all right, looks a little bit different than what we've seen before because we have 3 overlapping circles. All right, so I want to do this one with you because it's a little different. So this Venn diagram below shows the results of a survey when a group of people were asked, where did you visit on your most recent trip to Europe? Did you go to Paris, London, or Dublin? Or did you go to neither? Or did you go to 2 of them? Or did you go to all 3 of them? All right, so let's try to interpret this Venn diagram and answer the following questions. So first, how many people visited Dublin or London? So what we would want to do is look at our Venn diagram and look for the Dublin circle, which would be this one right here, all right? And we want to look for the London circle, which would be this one right here. So all of these people visited either London or Dublin. So we would include in our answer all of these people. So what we would want to do is add these numbers together. 76 plus 43 plus 24 plus 31 plus 64 plus 89. And when we do that, we get 327. So 327 people visited either Dublin or London or both. All right. Now let me clear off our Venn diagram so we can answer the next question. Erase, erase. Now, moving on to part B. How many people visited London and Paris? So to answer this question, what we want to do is look for the parts where it is overlapping and where we can tell where both people went to both Paris and London. So that would be this section right here. All right, so this is the part that's overlapping. That's where we can tell those are the people who went to both Paris and London. So we add them together. 64 plus 24 gives us 88. All right, now let me erase our Venn diagram. And let's move on to part C. So how many people visited London or Paris? So now we just want people who went to either Paris or London. All right, and so how we would find that is we would want to look at both the Paris circles and the London circles. So this is our Paris circle. So all these people went to Paris and all these people went to London. All right, so in order to find who went to Paris or London, they could have gone to either one of them. They could have gone to both of them. All right, or they could have gone to all three cities. So all of these people went to either Paris or London. So we do 95 plus 89 plus 64 plus 24 plus 43 plus 31. When we add all those together, we get 346. So 346 people went to London or Paris. All right, now let me erase our Venn diagram so we can use it again. Now, part D is asking us, how many people visited Dublin and not London? So who went to just Dublin, or Dublin? What was I saying? How do you pronounce it? Okay, it is Dublin. I just looked it up just to be sure. So Dublin. How many people just visited Dublin and not London? So we want to look for our Dublin circle, and that would be this one right here. And these people visited Dublin and not London. All right. But we also have to include these people right here because these 43 people, they did visit Dublin and they did not go to London. Even though they went to Paris, they went to Dublin and not London. So for part D, we would want to add together 76 plus 43. And that's going to give us 119. So 119 people visited Dublin and not London. All right, part E, how many people only visited Dublin? So what we want to do is look here and just look at the part of our Venn diagram where it's just people who visited Dublin. They didn't go anywhere else but Dublin. And that would just be those 76 people. So 76 people only visited Dublin. All right. Next, we want to look at part F. How many people visited Dublin and Paris? So we want to see where do Dublin and Paris overlap. So the parts where Dublin and Paris overlap would be right here. All right. So these are the people who went to both Dublin and Paris. So therefore, 43 plus 24 gives us 67. So 67 people visited Dublin and Paris. Part G, how many people visited all three cities? How many people visited all three cities? So we just want to look for the part where all three of them overlap, and that would just be this middle section right here. Only 24 people went to all 3 cities. So the answer to part G is 24. Then part H, how many people visited London? So to find that, we would want to look at our London circle. So how many people visited London? That would be all of these people right here. So all the people in the London circle. All these people visited London. So we would want to add together 64 plus 24 plus 31 plus 89. And that's going to give us 208 people total visited London. And then last but not least, how many people took the survey? And what we would need to do that is add together all of our numbers. So we would want to add together all these numbers of the people who visited Paris, visited both London and Paris, visited London, visited Dublin and London, visited all 3, visited Paris and Dublin, visited just Dublin. But we also have to include the 78 people who didn't go to either of the 3 cities because they were surveyed. They just didn't go to Paris, London, or Dublin, but they went somewhere in Europe. So add together all of these numbers, and when we do that, we get 500 total. So 500 people took the survey. All right, so that concludes our lesson on Venn diagrams. If you have any questions, please raise your hand, call me over so I can help you out. Otherwise, look to the board to see what to do next, and I hope that you have a great day.